December 24th, 1994. The coastline of northern Norway. This is the edge of the habitable world, where the Arctic Ocean meets the granite teeth of the Scandinavian peninsula. In the deep winter darkness, a drama of physics and mechanical failure began that would take nearly 20 years to resolve. The subject was the Soviet cruiser Murmansk. She was a relic of a fallen empire, a technological dinosaur designated Project 68 bis. While the rest of the world had moved on to guided missiles and radar-absorbent materials, the Murmansk remained a creature of heavy steel and high-explosive artillery. On this night, however, she was not a warship. She was 16,000 tons of dead weight at the end of a towing cable. The operation was supposed to be a standard commercial transaction. The Russian Federation was selling off the rusted inventory of the Cold War, and the Murmansk had been sold to scrap merchants in India. The plan called for a long, slow tow from the Kola Peninsula down through the Atlantic and eventually to the breaking yards of Alang. But towing a dead ship in the Barents Sea during winter is an exercise in managing chaos. The physics of a tow rely on the catenary curve of the cable. The dip in the heavy steel line acts as a shock absorber, damping the violent energy of the waves before it reaches the mounting points. When the swell height exceeds the length of that curve, the system loses its elasticity. The cable becomes a rigid bar of steel, subject to millions of pounds of shock loading. On Christmas Eve, the weather turned violent. A force 10 storm hammered the convoy. The tug struggled to maintain heading against wind and current, while the massive hull of the cruiser acted as a giant sail dragging the stern of the tug backward. The dynamic loads spiked beyond the yield strength of the towing gear. With a sound like a cannon shot, the tow line snapped. The connection was severed. In an instant, the Murmansk went from a cargo vessel to a rogue ship. Without propulsion and without steering, the cruiser fell victim to the prevailing wind and the relentless push of the Arctic swell. She drifted helplessly toward the village of Sorvere. There is a specific horror in watching a ship drift toward land. On the open ocean, a dead ship is just a navigational hazard. On a lee shore, it is a collision event waiting to happen. The Murmansk did not run aground on sand. She struck the jagged rock shelf off the island of Soroya. The momentum of 16,000 tons of displacement moving at the speed of the drift drove the steel hull hard onto the stone. The impact was not enough to shatter the ship immediately, but it was enough to trap her. She came to rest, listing sharply, effectively wedged between the underwater terrain and the pounding surf. This was a hard grounding. The keel was pinned. The double bottom was breached. In a standard shipwreck scenario, deep water claims the vessel and silence follows. The pressure crushes the compartments and the ocean hides the evidence. The Murmansk faced a different fate. She did not sink. She sat there. The superstructure remained visible above the waves, a constant reminder of the accident. For the people of the nearby village, the wreck became an instant landmark. But for the engineers and environmental regulators, it was a nightmare scenario. A warship is not just steel, it is a container for heavy fuel oil, hydraulic fluids, asbestos, PCBs, and potentially radioactive instruments. Most groundings are resolved quickly. Ideally, a salvage team arrives within days, patches the hull, and pulls the vessel free before the weather destroys it. But the Murmansk was different. The Soviet Union had collapsed. The ownership of the wreck was a legal gray area. The cost of recovery was astronomical compared to the scrap value of the metal. So the decision was made to do nothing. The ship was abandoned to the elements. For 18 years, the winter storms of the Norwegian and Barents Seas hammered the hull. The cyclic loading of the tides bent and twisted the steel frames. The cruiser became a permanent fixture of the Norwegian coast, a rusting monument to the end of the Soviet era. But steel has a fatigue limit. By the time the authorities realized the true danger posed by the toxic payload inside the hull, it was too late for a simple tow. The Murmansk had become part of the landscape, and removing her would require rewriting the rules of marine salvage. 16,640 tons. That was the full load displacement of the cruiser Murmansk. To understand why the ship could not simply be pulled off the rocks, you must understand the relationship between mass gravity and buoyancy. When a ship is floating, the water supports the hull evenly along its entire length. The pressure is distributed. The frame of the ship is designed to handle this uniform hydraulic support. But when a ship runs aground, that support vanishes. The hull becomes a beam bridge resting on uneven stone pillars. For 18 years, the Murmansk was subjected to a brutal cycle of mechanical stress. Every 12 hours, the tide would rise and fall. When the tide was high, the water provided some buoyancy, lifting parts of the hull, while the keel remained pinned to the rock. When the tide dropped, the water support vanished and gravity took over, pulling the massive steel structure down against the granite. This creates a phenomenon known as hogging and sagging. The steel plates flexed, weld seams opened, and frames began to crack. Welds developed microscopic hairline fractures that grew with every tidal cycle. The ship was not resting, it was being slowly bent back and forth until its structural spine snapped. During this long period of neglect, the cruiser became a ghost ship in the most literal sense. She developed a severe list, leaning over at 15 degrees to starboard. The interior compartments flooded and drained with the rhythm of the sea. Despite the danger, the wreck became a magnet for curiosity. This introduces a strange anomaly in the history of the salvage. The Murmansk became a playground for urban explorers. Local thrill seekers and tourists would swim out or take small boats to the wreck, clambering up the barnacle-encrusted hull to explore the rusting gun turrets. There are photographs from this era showing graffiti tagged inside the main battery directors and empty beer bottles left in the chart house. It was a scene of industrial decay that masked a lethal reality. These explorers were walking through a minefield of toxic hazards without knowing it. The insulation lagging on the steam pipes was packed with asbestos. The electrical transformers were filled with polychlorinated biphenyls or PCBs. The fuel bunkers still held heavy oil that had turned into a thick, black sludge. Every time a storm hit, the wreck would groan and shift, releasing small plumes of these contaminants into the pristine Arctic waters. The Norwegian government watched this slow-motion disaster with growing alarm. The wreck was deteriorating faster than anticipated. The initial surveys suggested the hull might last for decades, but the harsh Barents Sea winter was accelerating the corrosion. The steel was thinning. The risk of a catastrophic collapse was rising. If the ship broke apart completely, it would release all its stored pollutants, at once devastating the local spawning grounds for cod and haddock. This was not just an eyesore, it was an environmental time bomb ticking down in the surf zone. Then came the discovery that changed everything. It was not the oil or the asbestos that forced the government to act. It was a report regarding the specific equipment installed on a Project 68 BIS cruiser. Intelligence suggested that the fire control systems and the gauge dials inside the ship contained radioactive isotopes. Specifically, the fear centered on small radioactive traces from Cold War-era luminescent instrument paint and sealed sources in older dials and sighting gear. The casual urban explorers had been climbing inside a potential radiological hazard. The narrative shifted instantly. This was no longer just a shipwreck. In the public imagination, it became a radiological hazard sitting on an exposed shoreline. The option to leave the ship in place was removed from the table. The Murmansk had to go. To remove a shipwreck, the standard procedure is to restore buoyancy. You patch the holes, you pump compressed air into the tanks, you attach external lifting bags. You use the density of the water to do the heavy lifting for you. It is a collaborative effort between the salvage engineer and the laws of physics. But the Murmansk presented a logical paradox. The survey data revealed that the hull had lost its structural continuity. The steel plates were wasted by corrosion. The internal frames were compromised by 18 years of tidal flexing. If a salvage tug applied force to the towing points, the bollards would simply rip out of the deck. If floating cranes attempted to lift the hull, it would snap in half under its own weight. The ship was no longer a rigid beam, it was a collection of rusted metal held together by habit. The Salvage Consortium, AFDCOM, proposed a solution that inverted the problem. If the ship could not survive being floated in the water, then the water must be removed from the equation. They would not lift the ship. They would lower the ocean. The plan was to construct a massive cofferdam around the wreck, effectively building a temporary dry dock in the violent surf zone of the Arctic coast. This was an engineering decision of extreme audacity. It meant treating a marine salvage operation as a civil engineering project. The construction phase required a feature known as the mole. This was not simply a pile of rocks dropped into the sea. It was a calculated earth-moving operation that required extending the coastline of Norway out to the wreck site. Heavy dump trucks and excavators worked in the intertidal zone, fighting the very tides that had destroyed the ship. They hauled thousands of tons of local stone and fill material to build a double-walled breakwater. This structure had to be impermeable. It had to withstand the hydrostatic pressure of the open sea on one side and the crushing weight of the drying mud on the other. It had to be robust enough to serve as a road for heavy demolition machinery, yet temporary enough to be removed without a trace once the job was done. The scale of the investment reflected the severity of the threat. The budget for the operation was set at 239 million kroner. This sum was not for the value of the scrap metal, which was negligible in comparison. It was the price of environmental security. The government was paying for the certainty that every hazardous fraction, from fuel residues to PCBs, asbestos, and contaminated equipment, would be recovered. There could be no mistakes. A conventional lift might drop the wreck, spreading the contamination. A cofferdam contained the risk. If the ship broke apart during demolition, it would break apart on dry land inside the sealed basin. By the summer of the operational window, the trap was set. The arms of the breakwater encircled the cruiser. The massive pumps were installed capable of moving thousands of gallons of seawater per minute. The Murmansk was trapped in a man-made lake separate from the ocean that had claimed her. The engineers stood ready to activate the dewatering system, but this created a new critical danger. The ship was filled with water. The basin was filled with water. The pressure was equalized. As soon as they began to drain the basin, the pressure on the outside of the hull would drop, while the pressure inside the flooded compartments remained high. The rusted hull plates were paper thin. They could not withstand the bursting pressure of the water trapped inside. One wrong calculation in the pumping sequence would not just break the ship, it would cause the hull to explode from the inside out. 13,000 tons. That was the estimated mass of the rusted steel and hazardous waste waiting inside the cofferdam. But this figure was deceptive. This was not a solid block of metal. It was a honeycomb of corroded compartments filled with seawater. The salvage engineers faced a mathematical impossibility known as the bursting pressure paradox. The hull of the Murmansk was so fragile that the water inside the ship was actually acting as a structural component. If the pumps lowered the water level in the basin too fast, the pressure inside the ship would remain high while the external support vanished. The water trapped in the bilge and the lower decks would push outward against the paper-thin shell. The cruiser would not just break. It would effectively explode in slow motion, bursting open like an overinflated balloon. To navigate this minefield of physics, the team executed a technique called the soft drain. This was not a standard dewatering operation. They could not simply flip the switch on the high-capacity pumps and watch the level drop. They had to lower the water in agonizingly slow increments. It was a synchronized ballet of fluid dynamics. As the basin level dropped, they had to ensure the internal water level within the ship matched it inch for inch. They monitored the hull for the slightest sound of buckling steel. It was a process of extreme patience. The engineers were effectively gently setting down a 16,000-ton object that had been floating in a weightless environment for 18 years. As the water receded, the true condition of the Murmansk was revealed to the naked eye. It was a sight that no shipbuilder ever intended to be seen. The hull below the waterline was not a smooth steel surface. It was a chaotic reef of barnacles, heavy marine growth, and rust scales the size of dinner plates. The air inside the basin filled with the heavy organic stench of drying algae and exposed anaerobic mud. The ship looked less like a machine and more like a dying sea creature stranded by the tide. Then came the critical moment of transition. As the last few feet of water were pumped away, the buoyancy hit zero. Gravity reclaimed its total dominion over the vessel. The hull groaned under the strain. The steel frames, which had been supported by the density of the ocean for 2 decades, were suddenly forced to bear the full crushing load of the armor belt and the superstructure. The ship settled with a sickening lurch into the seabed. The list deepened. The metal shrieked as load paths shifted and welds and frames began to give. But the structure held. The soft drain was a success. The Murmansk was now stranded in a muddy crater of man-made dry land surrounded by the towering walls of the cofferdam. The problem now shifted from hydrostatics to geotechnics. The seabed was dry, but it was not stable. It was a layer of soft, shifting sediment that had never been exposed to the air. The plan called for heavy demolition machinery to drive directly onto this treacherous ground. If a 60-ton excavator sank into the mud, it would be trapped in the shadow of the unstable hull. The engineers had to build temporary causeways using rock and steel mats, creating a stable firing position for the demolition crew. The stage was set for the final act. The hydraulic shears were positioned. The target was the hazardous waste buried deep in the keel. The machines roared to life, and the first steel tooth bit into the flank of the Soviet cruiser. The image was surreal, where schools of Arctic cod had swum only weeks before heavy diesel excavators now tracked across the dry mud of the seabed. It was a demolition site located 30 feet below the natural surface of the ocean. The method of destruction was mechanical rather than thermal. In traditional shipbreaking, workers use oxyacetylene torches to slice the hull into sections. But the Murmansk was soaked in heavy fuel oil and potentially explosive gases trapped in the sealed compartments. An open flame was a recipe for disaster. Instead, the salvage team utilized hydraulic shears. These massive claws mounted on the arms of the excavators generated thousands of pounds of crushing force. They did not melt the steel, they sheared it cold. The demolition proceeded from the top down. The first targets were the iconic structures that had defined the silhouette of the Sverdlov class. The 12 main battery guns arranged in 4 triple turrets were the heart of the ship. Each barrel bore was 152 millimeters or 6 inches in diameter. For decades, these weapons had been the symbol of Soviet naval power projection. Now they were simply high-grade scrap steel. The hydraulic shears reached up and tore the turret housings apart plate by plate. The violence was precise. As the metal was stripped away, it was immediately sorted. Clean steel went into one pile. Contaminated material went into sealed containers. This sorting process was the critical bottleneck. The team was not just tearing down a building, they were dissecting a hazardous waste container. As the excavators chewed their way down to the waterline, they exposed the fuel bunkers. The black sludge had to be pumped out and stabilized before the steel could be cut. Then came the hunt for the radiation sources. Specialists in protective gear monitored the debris stream with Geiger counters looking for the specific components identified in the intelligence reports. Every gauge dial and every fire control sensor had to be treated as a radiological threat. It was slow surgical work performed with brute force tools. The stern of the ship presented the greatest challenge. The structure here was relatively intact, and the armor belt was thick. The excavators had to work in tandem. One machine would hold a section of the hull stable, while another tore into the supporting frames. The screech of tearing metal echoed off the walls of the cofferdam. Day by day, the gray mountain of the Murmansk was reduced to a flat stain on the seabed. The towering superstructure vanished. The main deck was consumed. The process revealed the ship's anatomy in cross-section, showing the tight crew quarters and the labyrinth of engineering spaces that had been underwater since 1994. However, the operation faced a new enemy: time. The cofferdam was a temporary structure built of loose rock and gravel. It was designed to hold back the sea for a single summer season. But the Arctic winter was approaching. The winter storms in the Barents Sea generate waves capable of shifting boulders and smashing concrete. If a major storm hit before the bottom of the hull was cleared, the waves could breach the cofferdam. The basin would flood instantly. The ocean would scour the demolition site, washing thousands of tons of loosened sludge and contaminated debris out into the open sea. The containment would fail at the worst possible moment. The excavators were no longer just working against the steel. They were racing against the inevitable arrival of the polar night and the storms that came with it. The deadline was absolute. 2013, the salvage contract was not merely for the demolition of a ship, it was for the restoration of a coastline. As the winter darkness closed in on the Arctic Circle, the crews worked double shifts to scour the final remnants of the Murmansk from the seabed. This was the forensic phase of the operation. It was not enough to remove the visible steel. The excavators had to dig down into the sediment to capture every fragment of metal and every shard of rust that had flaked off during the breakup. The goal was a zero-footprint outcome. The mud that had sat beneath the keel for 18 years was scooped up, tested for radiation and heavy metal contamination, and shipped away for treatment. When the last plate of the double bottom was lifted, a strange void remained. The dry dock basin was empty. The massive imprint of the cruiser was visible in the clay, a fossilized shadow of the warship, that had rested there since 1994. But the engineering challenge was not over. The artificial peninsula known as the Mole, which had been constructed to facilitate the attack, was now an obstruction. The contract required the landscape to be returned to its exact pre-accident condition. The massive breakwater walls had to be dismantled stone by stone. This process was the reverse of the construction. The pumps were silenced. The sluice gates were opened. For the first time in 3 years, the Atlantic Ocean was allowed to reclaim the bay. The water rushed in, swirling over the scarred seabed where the cruiser had died. As the pressure equalized, the excavators retreated to the shoreline, tearing down the road behind them. The granite boulders that had formed the cofferdam were removed and redistributed. The man-made dry land was erased. The statistics of the operation were a testament to modern industrial efficiency. Over 95% of the Murmansk was recycled and repurposed. The steel that had once formed the armor belt of a Soviet Leviathan was melted down and returned to the global supply chain. The toxic legacy, including the feared radioactive isotopes and the thousands of gallons of fuel oil, was neutralized in secure facilities. The environmental disaster that had threatened the fisheries of northern Norway for 2 decades was averted not by a daring sea rescue but by methodical terrestrial engineering. Today, if you stand on the cliffs overlooking the village of Salvaging, there is nothing to see. The water is gray and restless. The surf breaks against the rocks without obstruction. There is no rusted superstructure cutting the horizon. There are no gun turrets pointing silently at the sky. The physical evidence of the Project 68 BIS cruiser has been completely obliterated. The Murmansk holds a unique distinction in naval history. She was the last all-gun cruiser to be wrecked, and she was the only warship of her size to be consumed entirely on site. The disappearance of the Murmansk marks the final end of an era. The gun cruiser was the dominant predator of the oceans for the first half of the 20th century. These ships were defined by thick armor and heavy artillery designed to fight within visual range. The Sverdlov class was the final evolution of that lineage. When the hydraulic shears cut the last section of her keel, it was not just the end of a single ship. It was the definitive conclusion of the age of the gun. The ocean floor is now clean. The radiation is gone. The ship that refused to sink was finally forced to vanish, leaving behind only the cold, clear water of the Barents Sea.